Hello, mathematicians. We are working on lesson 6. We are working on literal equations. These are important in math, but even more importantly, they are important in physics. You will be using this in science. You will be so happy to know how to do this when you get to physics. Okay, so literal equations are basically equations with multiple variables. So I'm going to show you, you're going to use the same steps that you use to solve two-step equations to solve literal equations. They just have variables involved. So let me show you. Remember, we're going to use the same steps we always use. Notice that I have a 2x minus 5 equals 13. This is my constant. This is my coefficient. We make our constant 0. So I'm going to add 5 and add 5. I'm going to rewrite it so it's not so messy, and I get 2x, this is a 0, equals 18. Now this is my coefficient. I want it to be a 1, so I'm going to divide by itself. It becomes a 1. Whatever I do to the one side, I do to the other, and I get x equals 9. Nice and pretty. This works out because a lot of our numbers kind of end up canceling each other out. It gets a little bit trickier when they're all variables, but we still take the same steps. Notice that I want to solve for x. I want x to be by itself. So I need to remove my add or subtract first, which is, this is my constant. So if I have a negative b, I'm going to move it by using a positive b. That becomes 0. But whatever I do to one side, I do to the other. So now I'm going to rewrite. I have ax equals c plus b. I can't actually put c and b together because they're being added and there's not a value there. Okay? But notice that my ax still looks like my 2x. So now I want to get my x by itself. Remember, our goal is to get x by itself. X by itself. So how do I get x by itself? Well, I take my a. I want this still to be a 1. So I'm going to have a divided by a, which is 1. Remember, anything divided by itself is still a 1. So a divided by a is 1. Now, whatever I do to one side, I do to the other. I divide by a. Now, I can rewrite this to make it look not so messy, but x is going to be equal to c plus b divided by a. I can't combine anything because we're using different operations. So, a couple of things that I notice. It would be good if you go ahead and write this first. What do you notice? But these are the things that I noticed. They both use opposite operations to isolate the needed variable. Notice I used a positive 5 when I had a negative 5. Notice I used a positive b when I had a negative b. Notice that I divided when I was trying to isolate 2 times 6. Notice I divided when I was trying to isolate a times x. Okay, second thing I notice, the literal equation doesn't simplify nicely because of all the variables. Take a look here. This one looks kind of messy, but it's the right answer. Let's try a few ones and one-step problems, and then we'll try a few multi-step problems. Okay, so always look for what you're solving for. We are solving for w. So notice in this one, I'm going to solve for w. I want to isolate the w. I notice that this is L times W, so I'm just going to divide by L to make that a 1 and divide by L. So now W is the same thing as A divided by L. Let's take a look at number 2. Number 2, I want to solve for H. Here's my H. I notice that my H is being multiplied by B, so I'm going to divide by B. That becomes a 1. But whatever I do to one side, I do to the other. So now I have H is equal to A divided by B. I think you get the hang of this side. Let's go ahead and work on a few of the two-step problems. So whenever you're using multi-step problems, remember you're kind of going backwards from PEMDAS. You're going to do adding and subtracting first. You're going to remove the adding and subtracting. Then you're going to remove the multiplication and division. So let's go ahead and do one that has everything. So let's go to number 13. We'll go to number 13. in this one, we have P equals 2 times L plus 2 times W, which is actually perimeter of a rectangle. But let's go ahead and solve for W. Okay, that means I need that W all by itself. So since the W has to be by itself, I need to move my 2L first. Think of that as your constant. So I'm going to subtract 2L and subtract 2L. Whatever you do to one side, you do to the other. Always rewrite. So now I have a P minus 2L. See how I kind of put that negative 2L first? That becomes 0 equals 2W. Okay, now I still need my W isolated. And I notice that my W is being multiplied by 2. So I need to turn this into a 1, or do its opposite, divide. That is now a 1. Whatever I do to one side, I do to the other. So I have to divide the entire other side by 2. So now I can rewrite this. I've got W is the same as P minus 2L divided by 2. And I have isolated my W. Okay, let's go ahead and do one more. And let's do number 16, because number 16 looks a little messy also. We are going to solve for T. So here's my T. I notice that T is being multiplied by P and R, and it's being added to P. So let's go ahead and move this P first. Since this is a positive P, I'm going to use a negative P to move it. Whatever I do to one side, I do to the other. And always rewrite, especially with all these variables, A minus P equals PRT. Now, I still want to get this T by itself. So I want to do this in one step. Notice that this is P times R times T. So they're all being multiplied. So I'm just going to divide. And since I want to divide out the P and the R, I'm going to put P and R down here. Because look, that's still a 1. PR divided by PR is 1. But whatever I do to one side, I'm going to do to the other, PR. So now I can rewrite it so it's not so messy. I've got T is equal to A minus P divided by PR. Okay, go ahead and do 5 on your own, then go ahead and jump into Delta Math. And remember, you're totally going to need this in science. You need it for physics.